Okay, in this video we're going to look at Kirchoff's current and voltage laws. Something that we've actually already been doing, but we just haven't called it by anything. So starting off with then the current laws. So the sum of the currents entering a point, we call a point a node. So the sum of the currents entering with I1 and I2 here, then equals the sum of the currents leaving. Well, in this case, there is only one path leaving, so I1 plus I2 equals I3. So if we take this example here, we've got 1 amp going in on I1, 5 amps going in on I2. So therefore, what do we get coming out? All we have to do then is add them together. So 1 plus 5 is 6 amps. Nice and easy, eh? All good. Okay, so if we take this circuit here, so I've got 3 amps flowing into the junction of a parallel network, and I want to know what I1 and I2 are. Okay, well we know the value of resistor 1, which is 12 ohms, so let's get cracking with some calculations. So we can straight away say that, well, the current I1, we know there's going to be 12 volts across it. It's a 12 ohm resistor, so the current going down there is 1 amp. Okay, 1 amp flowing down through that 12 ohm resistor. So therefore, well, if we know our total current is 3 amps, then our I2 then is going to be our I total minus by I1. So 3 minus 1 is 2 amps. So I2 is 2 amps, beg your pardon. The one last step we can do is if we know now the voltage, we already knew that the voltage was 12 volts across R2, and now we know there's 2 amps flowing through it, we can work out the resistor value. So 12 divided by 2 is 6 ohms. So if we move on to the voltage law, there's a couple of different ways of describing the voltage law. Let's take it nice and simply. The sum of all the voltages across all of the components equals the supply voltage. Okay. Sum of the voltages in the circuit equals the supply voltage. You can see that in this example here, if I've got 9 volts across one resistor, 3 volts across the other resistor, then my original supply voltage that I've got is going to be 12. Okay, another example here. So we've got 18 volt battery, 10 volts across one resistor, 2 volts across the resistor. We don't know what's across that final bottom resistor. So what do? Well, we know that the 10 plus the 2 plus something else is going to add up to the 18. So there we have it. 18 minus 2 minus 10 equals our 6 volts. Okay, one last question for us. So we've got 4 ohm resistor, 2 amps going through it. So if we want to know what the voltage is across that unknown resistor there, then if we work out what the voltage is across that 4 ohm resistor, then that will tell us what the voltage is the unknown. So voltage equals I times R. So 2 amps times by 4 ohms equals 8 volts. 9 volt supply. So it doesn't take a genius to work out that there's only going to be 1 volt across that lower resistor. Now that we know that there's 1 volt across that lower resistor, if we wanted to, then we could go that step further and work out the resistor value. So 1 volt divided by the 2 amps flowing through it gives us half an ohm. And I think that's about it.